Hello and welcome back. For this video, we're going to show how to solve equations with the variable on each side. Over here, you can see what our goals are. We're not going to cover all these goals today because this is actually a 2-day lesson, so some of them we'll cover in the next video. And that also includes the vocabulary of identity down here. That would be in the next lesson. Now, there is a PDF that accompanies this video. You might want to download it, print it out, and place it in your binder, and it should look like this. And these are the steps that we're going to use from here forward to solve multi-step linear equations. Now, the majority of what we're going to be doing is going to be focused on step 2, which says move a variable. What we really mean by that is eliminate a variable from one side or the other. And then step 3, which is isolate that variable using reverse PEMDAS. Now, we will use a little bit of combining like terms from the top, distributing, and clearing fraction on today's video as well. Example 1, they want us to solve an equation with the variable on both sides. So the first thing we want to do when we look at this is decide which coefficient on the variable is smaller. So we can clearly see that the 4 on the a is smaller. So we're going to eliminate the 4a from the right side using the reciprocal operator, which is minus 4a. But I have to keep this thing in balance, so I'm going to minus 4a on the other side as well. The right-hand side becomes 0, and 0 minus 13 leaves us with 13. The left-hand side, you'll notice the 5 comes down. It was not affected, nothing to combine with. But on the 7a and the 4a, we only do the coefficients, or the calculations on the coefficients. So it's 7 minus 4, which will give us 3, and the a kind of comes along for the ride. On this level here, all we have is a 2-step problem, and we're going to use the reverse order of operations to solve, which means the first thing we're going to undo is get rid of this 5 by using the reciprocal operator of minus. So we're going to minus 5 on both sides, and when we do it on both sides, that's called a property of equality. The left-hand side here becomes 0. 0 plus 3a is just 3a. On the right-hand side, negative 13 minus 5 will give us a negative 18. Now we're almost done. We're not quite there yet because we don't want any number in front of a other than 1. So we have to get rid of that times 3 using divide 3 on both sides. You see that they've gone ahead and done that here. But one thing you want to remember here, when you take 3 divided by 3, it does not become a 0 like the 5s did up here. It becomes a 1, and 1 times a is the multiplication identity, which is just a. And of course, on the right-hand side, negative 18 divided by 3 is just going to simplify to negative 6. Now, one thing you're supposed to do once you got an answer that you think is right is you're supposed to go back and check it, and that's what they've done right here. They've substituted a with the negative 6. They've worked down all the problem, and at the very end, they see the left and the right-hand side are equal, and because that's a true statement at the end, that means our negative 6 is the solution. For example 2, they want us to write an equation with the variable on each side. And the scenario they have here is a hot dog eating contest. They have the winner or the champion for the men and the women, and they're going to put the man against the woman in a competition. And they want to make this competition a little bit more interesting, so they're going to let Matt not start. It says right here, Matt will not start until Mickey, that's the woman, has eaten 20 hot dogs. Because if you look over here in the table, you can see he eats 62 hot dogs in 10 minutes, and she's only eaten 38 in 10 minutes. That's her fastest way of eating. So he's a little bit faster, so he's going to give her a 20 hot dog lead. So they also tell us that we want to assume that Matt and Mickey eat at a constant rate throughout the competition. This is all based on 10 minutes from their previous competition. And they want to know, the final question is, how many minutes after Matt starts eating will they have eaten the same number of hot dogs? So essentially, we're going to say that Matt's number of hot dogs needs to equal Mickey's number of hot dogs, and that's our general equation. We just got to put in the specifics related to how many hot dogs Matt eats, how many that Mickey eats, but everything is based on hot dogs. So it says Matt eats, and I think it was 62, 62 hot dogs in 10 minutes, and we want to create a rate out of it, and a rate is always something that you're going to multiply in your problem, but the way we calculate the rate is we take how many hot dogs he ate over 10 minutes, and he's eating at a rate of 6.2 hot dogs per minute, 6.2. Then they want to know the number of hot dogs he actually eats after m minutes then is going to be, well, how fast is he eating? 6.2 times the number of minutes. Like I said, rate gets times, so we get 6.2 m. Now, Mickey eats 38 hot dogs in 10 minutes, and we got to calculate a rate for her as well. And we're going to do the same thing as before, so it's 38 divided by 10, and that comes out to 3.8 hot dogs per minute. Now, she is given a 20 hot dog head start, so the number of hot dogs that she will have eaten by the time m minutes have passed, remember that's after Matt starts, So when Matt starts eating, she's eating at a rate of 3.8 m, plus she already ate 20 before he started eating. So that 20 is a fixed number before they even get started. Now we want to write the equation. So remember, we had Matt's hot dogs equals number of hot dogs eaten by Mickey. So Matt's was 6.2 m, and Mickey's was, and it's right here, her number of hot dogs right there, which is 3.8 m plus 20. So now all we have to do is solve, and you see they've got the problem written here. First thing I'm going to look at is the coefficient of each of the variables and eliminate which one ever is smaller. So 3.8 is obviously smaller, so I'm going to eliminate by minusing 3.8, minus 3.8 m on both sides. And the reason I do that is I want to have variables only on one side, but the reason I get rid of the smaller one is so I don't end up with a negative coefficient in the end. On the right-hand side, we have a 3.8 minus 3.8, which is going to give us 0 m, so that zeroes out, leaving 20 in the problem on the right-hand side. The left-hand side, we have 6.2 m minus 3.8 m, which is going to give us 2.4, so we're almost there. But we have to get rid of that 2.4, and that's multiplying with m, so to undo that, we're going to divide by 2.4 on both sides. You can see they did that here and here. Now the left-hand side, 2.4 divided by 2.4, eliminates each other, but not to a 0. They become a 1, and 1 times m is a multiplication identity. So that gives me just m. This little symbol that they have right here, that's means approximately equal to, not exactly equal to. And you'll see why here. 20 divided by 2.4 is going to give us about 8.33, and it's actually a repeating 3. So down here where it says approximately blank minutes, so I'm going to change that. I'm going to convert this to a fraction because I know what that is as a fraction. That's 8 1/3 minutes. After 8 1/3 minutes, Matt and Mickey have eaten the same number of hot dogs. Go ahead and pause the video and try the check. Let's go ahead and solve this. This one's a basketball one. It's related to Nolan and Victor, and they are the top scoring freshman players in college basketball from last season. The table below shows how many points Nolan and Victor scored and how many games they played. So we've got two things, how many games and how many points each one of them played. The points that Nolan and Victor scored this season will be combined with their points from last season to give their total career. So this is over 2 seasons. This season, Nolan is hoping to catch up with Victor and have the same number of career points. So what that means is we want Nolan's points to equal Victor's points. Remember, these are in points. So there's our general equation. We just got to fill in the specifics now. We want to assume that Nolan and Victor play every game and score at a constant rate. So we need to calculate a rate. So we're going to calculate Nolan's rate. And that's going to be his 750 divided by 30 games. And that will give us 25 points per game. And then we'll calculate Victor's rate, which is 782 points over 34 games, and his rate was 23 points per game. Let's move on to part A. It says, based on each player's average scoring rate, write an equation that represents the number of games it will take Nolan to accumulate the same number of career points. So write an equation to represent the number of games. So our variable is going to be the number of games it takes. And if you look down here, you see that 25 is on the left, and we calculated Nolan as 25. So this must be Nolan's information. And P is the number of games, so 25 points per game for this season. But what's missing is last season's data, which is 750. On the other side, we have Victor, so his was 23 points per game, so 23. Remember, rates are always times by something, usually our variable. And his last season point totals were 782. So this is going to be the number of points scored after 2 years for each of them. All we got to do is solve it to find out how many games it's going to take for Nolan to catch up. First thing I want to do is look at the variables. So we're going to see that the 23 is a smaller coefficient than 25. So we're going to subtract 23p from both sides, minus 23p. What's left over is 2p on the left, plus 750. The right-hand side will give me 0p plus 782. That's an identity, leaving 782. I'm going to write that off to the side. Now we just have a two-step equation. We're going to undo that by getting rid of the 750 first. So 750s cancel out to a 0. 0 plus 2p is a 2p. That's an identity. 782 minus 750 leaves us with 32 points. Divide both sides by 2 to isolate the p completely. Now remember, this becomes 2 over 2 is 1, not 0. And 1 times p is p. And 32 divided by 2 is 16. So it takes 16 games. Come down to part B and let's fill that in. 16 games. Example 3 wants us to solve an equation with grouping symbols. And the way we get rid of grouping symbols is usually we'll distribute. So the first one here, we have a distribution of 7 with the n, 7 with the -1, and that gives us 7n minus 7. On the right-hand side, we got to be careful here. We're distributing a -2. So -2 times 3 is -6, and -2 times n is -2n. Now we got to decide which variable we're going to eliminate. Well, the -2 is obviously got the smaller coefficient, so I'm going to eliminate that by doing the opposite of -2, which is plus 2n. And I have to do that on both sides to keep this equation balanced, because that's a property of equality. Right-hand side zeroes out. 0 plus -6 is -6. The left-hand side, I'm going to use my commutative bars here. So 7n plus 2n gives us a 9n, and notice that the -7 just came down. There was nothing to change about that one. Now we got a two-step problem, which means we're going to do reverse order of operations. So we're going to get rid of the -7 first. That would be plus 7 on both sides. 7 and -7 makes a 0. 0 plus 9n is 9n. And -6 plus 7 is 1. And the last thing to do is to undo the times 9. So we're going to divide 9 on both sides. And 9 divided by 9 again is 1, not 0, leaving us with n. And I'm just going to leave this as a fraction of 1/9. Go ahead and pause the video and attempt the check. Okay, let's take a look at the check. First thing we're going to do is distribute. I'm going to write this off to the side. So 7 times n, 7 times -2 would give me 7n minus 14. Bring the plus 8 over because we didn't do anything with it yet. And that's going to equal. Then we got to distribute the 3 to eliminate the parentheses. So 3n. Or 3 times n, 3 times -4, that's going to give me 3n minus 12. And then don't forget to bring the -2 over, because that was not affected by the distribution yet. Now, before I start moving variables around, I should continue to combine like terms. And I just noticed this is a plus 8, not a minus 8. So we're going to combine the -14 and the 8, and that becomes -6. I'm going to bring the 7n down because I didn't combine it with anything. So I have 7n minus 6 on the left. On the right-hand side, I'm going to bring 3n down, and then I'm going to combine the -12 and the -2, and that's going to become -14. Now I can go back to eliminating my variables. Well, the 3n has a smaller coefficient, so I'm going to get rid of it, make it a 0 by subtracting 3n from both sides. So on the left-hand side, 7 minus 3 gives us 4n. Remember, we do calculations on the coefficients only. Bring the -6 down because I didn't do anything with it. And on the right-hand side, we have a zeroing out again. So 0 minus 14 gives us a -14, so that's an identity. Now it's a two-step problem. Get rid of the 6 first by doing opposite. So plus 6 plus 6. This zeroes out. 0 plus 4n leaves you with 4n. Equal to, on the right hand side, -14 plus 6 is -8. And the last step is to get rid of the times 4 by dividing by 4 on both sides. And remember, 4 divided by 4 is 1, not 0. And that leaves us with n, which we have on the left hand side already. And -8 divided by 4 is going to leave us with a -2. So n should equal -2. Example 4, they want us to solve an equation that has a fraction bar. Well, that just means we're going to eliminate or clear the fraction. And the easiest way to do that is to multiply everything on both sides by the least common denominator. Well, there's only one denominator. So if you look down here, they've already put parentheses on around the fraction. And the only denominator to get rid of is a 4. That means divide by 4. So to undo a divide, we're going to times by 4. But to keep this equation balanced, we have to times by 4 on both sides. Now the left-hand side is pretty easy. So just 4 times 5y will give us 20y. The right-hand side is still pretty easy as well. If I times the right-hand fraction with 4 and then turn right around and divide it by 4, they end up canceling each other out to a 1. So that gives us an identity again, 1 times 12y plus 16. And we're left with 12y plus 16 because it's an identity. Now I got to decide which variable has a smaller coefficient, and that would be the 12. So to eliminate the 12y, we have to subtract 12y from both sides. And we're only eliminating it from the right-hand side because this right here gives us a 0, and 0 plus the 16 is 16. The left-hand side is going to be a 20 minus 12y, and that's going to leave us with 8y. Now to get rid of the times 8, we're going to divide both sides by 8. And again, 8 divided by 8 is 1, not 0. 1 times y is an identity for y. And 16 divided by 8 is 2.